Hello, students. Today, before giving out the topic of the session, I would like you all to guess it by giving you a simple clue. Name the physical quantity which causes motion in a body. Yes, the physical quantity is force. You apply force on the pedal of the cycle so that the cycle moves, right? So today we are going to study the effect of force on bodies, such as this green ball, which is like a rigid body, hard, and a soft, that is non-rigid body. So let's see what happens when forces are first applied on a non-rigid body. Yes, definitely the non-rigid body can move. If you throw the ball, it will move, it will bounce, and it will also change its shape. So force can also change the dimensions of a non-rigid body besides causing the motion in it. But what happens when force is applied on a rigid body? Definitely, when you apply force, this rigid body also moves. But what when you press it? Well, here the force can only cause motion on a rigid body. It cannot change the dimensions. So the learning objective of today's class is to understand two kinds of motion produced because of force acting on a rigid body, and that will be linear or translational motion and rotational motion. Say, for example, you have a stationary rigid body and you apply a force from the left side. There you go. The stationary rigid body moved in the direction of the force. So what kind of motion is this? Yes, that's linear or translational motion in a straight line along the direction of the force. But this will happen only when the rigid body is free to move. It is not attached anywhere. Let's see if you have a body which is pivoted at a point. Like you can see here that there is a pivot. This rod is pivoted. This is the pivot. Okay, so now if I apply a force in this direction, what would happen? It will start rotating. It will move in a circular motion along an arc. And that's what we call as rotational motion. Now this happens to a stationary rigid body when it is pivoted at a point. Here you have a wheel which is pivoted. This is the pivot. This is the pivot. So you have the axis of rotation passing through this pivot. And now, if a force is applied along the tangent of the wheel, if wheel is circular, so tangent is, this is along the tangent. What happens? The wheel starts rotating. So again, this is rotational motion, and this rotation is happening about the axis. And the axis is passing through the pivot of that wheel. So this is what we know as the turning effect of force. So this is the topic of our next session. But before we move on to the next session, I have a small question for you. We see rotation motion when we open the door or shut the door. So this is what is the turning effect of force on the door. So the question of the session is, where does the axis of rotation of the door lie? Yes? So until we begin the next session, think about it. Thank you.